and we're going to do kind of an activity later that demonstrates how gases work in a closed container. But before that, I want you to take some notes, and the paper that you guys got are just going to act like as your interactive science notebook for now. You can write whatever you want to write down. There are specific things, though, on each side that I'll tell you to write down, just to remember for later, but you can write down the reviews on it. Okay, so just to start off, kinetic molecular theory is that all matter is in constant motion. Solids, which we're just going to talk about them briefly, are, when they're closed in a container, they're compacted so tightly that they just vibrate against each other. And liquids are almost the complete opposite. They sort of move freely in a liquid, so that's why when you pour it in another cup, it takes the shape of that container. If you were to pour it in something shaped like an S, it would take the shape of that container. Gases are the complete opposite. They move whatever direction they want to, however they want to. The only thing about gases is that when they bounce off the wall, they'll come back at the appropriate angle. So they'll go this way and bounce back off that way. Okay, so you don't have to write all of these down. I would maybe just do the first two bullet points. Like I said before, in solids, they're compacted so tightly together, there's no empty space. Liquids, there's a little bit of empty space, but they're constantly moving. And gases, there's more empty space than a solid or a liquid. There's also no force of attraction between them, so that's what gives them the power to move wherever they want to. Also, they're random. Their motion is random, constant, and rapid. So they'll move fast, depending on the temperature. They will not, one gas particle is not going to move faster than the other one. So you have your closed container, and you have a gas particle and a gas particle. One's not going to be like this, and one's not going to be like this. They'll move at the same speed. They also move in a straight line, and they bounce off the walls. They experience elastic collisions, which is different than solids. Solids, I told you, were tightly packed, and they kind of vibrate off of each other. Liquids just kind of bounce off of each other, but gases will, almost like elasticity, it stretches, and it just bounces right off of each other. Okay, so these things are what we're going to use to figure out how volume and pressure affects like temperature and stuff in our activity. So I want you to write down everything that's on this next slide, just because we'll use it for our problems. So gas properties depend on volume, which is the amount in the container, temperature, and the higher the temperature, the higher the energy, the lower the temperature, the lower the energy. That seems a little obvious. Oh, also, for converting temperatures to Kelvin, does anybody know how to convert a temperature to Kelvin?
You add 253 degrees.
270. So if something is 30 degrees Celsius, you'll add 273 to that, and that's what you'll use in your problem. Also, we won't be using this today, but this is important for later when we work out our problems. N is the number of moles, and in later problems when you do pressure and volume equals number of moles times temperature, that's when that will come into play. Oh, and then this is also important because pressure, which we'll talk more about in the next slide, but it is the number of times a particle bounces off the container.
You go back for Stop, guys, I didn't get this all down. She said I wrote it all down.
I didn't either.
Thank you, Liz.
Your face.
Closer.
Yeah,
Liz probably can't see.
Oh, I have my glasses. I forgot.
This is super. Liz is sitting back here like this. This is Puerto Rico.
I have two glasses just in case. What?
No way, were you?
Wow.
You look really tan.
Look good, bro.
Thank you. I got my hair lighter, so
I noticed.
that's
pretty
it.
good.
Wow.
Okay.
I can
Does
see
everybody get this down?
clearly now. Okay.
Yeah. Yeah. We're all good.
I had to get my glasses. Hold on. You want to see the like temperatures and others? What did we say was the Kelvin something?
Celsius
so when
plus-
you have Celsius, whatever you have in Celsius for temperature, you're gonna add 273 to get the Kelvin temperature.
Okay. Thank you.
You got it? Okay, so this is what I just said about pressure. You don't have to write this down, just keep this in mind for when we do our activity. It's the number of times you bounce off, or a gas particle bounces off the wall of the closed container. It's also measured with a barometer, which is not what we're going to use today because it's a little more skilled than what we have today. I have a picture of it though. So if you were going to be a chemist, this is what you would use in the lab, but today we're going to use people instead of the barometer. Okay, so the ones that I want you to write down are the ones that have the asterisk next to them, just because those will be the ones that we use most often. So one standard atmosphere, which we'll abbreviate as ATM, is equal to all of the things that will be listed. Okay, so the things that we're going to use the most will be the atmosphere, the millimeters of mercury, and then the kPa, which is kilometers Pascal.
Which one's mercury?
Hg.
What?
Mercury.
Remember this.
I remember the Pascal because my chem teacher last year just
So once everybody gets at least one of the actions written down, we're going to do a couple of practice problems with them and see, we'll use dimensional analysis to work through. Is everybody good?
Mm-hmm.
No.
You have to write them out.
Those are some sweet
I
shit.
will.
Oh my gosh, wait. I think those are my sister lost.
You guys good?
Yeah, like
Okay. So, what is 475 millimeters of mercury, millimeters of mercury expressed in ATM? So, setting it up, that's how we're going to start to set it up. So you'll have
Oh.
dimensional analysis.
Okay.
This was
That's a train track.
I thought I
That's
read
train tracks. Okay, so you want to set it up so millimeters of mercury cancels out. That's why it's
I
not on
love
top. It's
this.
going to be in the denominator. And remember that 760 millimeters of mercury is equal to 1 atmosphere. Okay? So that's how we're going to set that up. Does anybody have a calculator?
I do.
They
I got my cell phone.
this list.
165.
Okay.
And that would be atmospheres because our. You want to do the next one? Do you want to do the next one? Sure. Okay.
Okay.
Okay. So how would we set this up?
Oh. 14.7 goes on the bottom.
Okay. So what goes on the side?
Yeah.
This one. Okay. So let's talk through this one for a second. So this, because these two are equal to each other, just like they're both equal to 1 atmosphere. That's why we set it up like this.
1,520.
It's okay. Because we're trying to find what it is in millimeters of mercury. So what did you say it was, Leah?
1,520.
I'm so confused how you pulled
Wait,
up
don't you
the
multiply-
14.7.
You divide, then multiply.
14.7 PSI.
Wait, do you multiply
29.476 and then divide it by 14.7 and that's what you got.
Where did you get 14.7?
That was one of the units of measurements that's equal to 1 atmosphere.
Oh, I didn't write it down, that's why. Instead of
Okay.
Whoa.
So you don't have to write any of this down. Don't worry. Okay, so I need 6 volunteers for this next part. This is where we're gonna act as gas particles.
Heck yeah.
Okay.
I'll do it.
You guys will do it. Okay. I need
Jillian will do it.
Julie, come on.
Come on, Jillian.
Okay. So let me.
I'm gonna go, and then like I'm gonna write.
My teacher has been doing things right.
We got there at the same time.
Okay, so all the directions are up there. You guys, I'll give you one in a second.
I didn't get one.
Too bad.
I gave you
Well,
5.
Where's the other one?
What hour are we in? We need another one too.
Okay,
I think we're in our 16th. It's 6 hours.
16th hour?
It's 6th hour right now.
16.
Yeah. Yep. It's
16
6
sounds
hours.
good.
She goes 147. You can't even tell.
Okay.
You were like, look at the top
Right now, like, wow.
You're junior high school.
Because ours is blocked.
Okay, so the first 5 things on the numbered list are just what the kinetic theory says about gas particles. Gas particles are in constant random motion. They move in a straight line until they collide with an object. So when you guys are moving in the box, if you hit the wall, you're going to bounce off this way, okay? And then you keep going. If you run into each other, you're going to do the same thing. Now, let's try not to hit each other hard when we run into each other.
Someone clock us.
Okay, they also have They also have perfectly elastic collisions, and temperature is directly related to the speed.
I'm
So
pretty
a little-
hot, so.
In a little bit, we're going to change the temperature, so we'll speed you guys up, and we'll decrease the volume. Okay. Also, gas pressure derives from particles hitting the surface. So, like we said before, when you hit the inside of that object or the container, that's pressure. Okay. So, the purpose of this is to demonstrate kinetic theory and the relationships between temperature, pressure, and volume and particle number.
Huh?
We'll work it out in a second. Okay, so in the classroom, you're going to see, obviously, the space has been defined. You're going to act as a gas particle, so each of you are a gas particle. You're going to move at a constant speed. So the speed you're going to move at is going to take 1 step every time you clap. Okay? Okay.
She's like a dinosaur.
Bouncing off each other and walls at appropriate angles are what you guys are going to be doing, okay? You need to keep track of how many times you hit the wall. If you hit a person, that doesn't matter. You want you to count how many times you hit the wall. So make sure your
What
focus.
is the wall?
Yeah, this is not, imagine this
No,
one's
she's
not
talking about the
right.
walls.
Okay. That is not-
So that doesn't matter.
that doesn't matter. So
Right, this isn't
focus on counting, okay? Focus on counting. Okay, so let's start with the first one. The first, we're going to call them sessions. All students are moving at 1 step per second. So each time I clap, you're just going to move a step. Okay? So let's try.
What's your arms like that?
Why
are your arms
so
so big? Boxing people out.
Does it watch you on the edge? Can you turn a minute for me?
I can't have it backwards. You're gonna move. Oh, session A, everybody try to
Okay, ready?
Oh.
All right.
Alright. Liz.
I thought you said that we like go before.
Liz is just going in circles. Yeah, Liz. Liz is all over the place. Oh, you purposely did that. Oh, God. Out of the box. That's not how gas moves. We just learned.
Yeah, I'm really what?
Liz is going like this.
Somebody
Like in the middle of the
and
thing.
hit a wall, and then you're gonna bounce back because you're a freaking wall.
Liz is just going where there's not people.
Now we're just going in circles.
Gonna break this circle.
Okay, you guys can stop. Okay. How many times did you hit the wall?
I didn't count.
70.
I didn't
Let's just go with the 30.
I didn't
count.
27.
I forgot.
No, I swear to God, that was it.
11. Okay, we're gonna do it one more time. Make sure and count this time. Okay?
She would have had to hit a wall every time.
I believe
Okay,
it.
make sure you focus on counting this time. Okay?
Okay, here we go.
Go.
Someone please tell me how I'm doing it wrong.
gas molecules can't be bullies.
Hey, hey.
Hey. We need some music.
I can play We Are the Dinosaurs.
No, you done.
Yes.
Oh, like go with constant emotion.
I'm stuck. God damn.
I love that song. One rough right now.
Okay, you guys can stop. Okay. How many times bring in the wall?
16.
Okay.
13.
Okay.
16.
14. So you went from 27 to 14 wins.
15.
Brianna wins.
Okay, so we got 91. So on the back of your sheet in box A, you're gonna put 91. Okay? Okay, so this time you're gonna move, I guess, a step faster. So you're gonna speed
Oh
up.
man.
So speeding up, if we are speeding up, what does that mean we
I'll put
increase?
one on.
Temperature.
Woo!
What pressure?
Are you learning something?
And you guys had 91 correct.
Okay, so you guys are gonna still count every time you hit the wall, and this time we should get a smaller or bigger number?
Bigger.
Bigger.
Liz, how did you get your numbers?
Okay,
What if you did like 18? Start over.
clapping. Each time I clap. Okay.
Holy.
Okay, ready?
Oh my god. I'm just gonna take twice as long as this
Liz, get his arms moving from those calories.
guy. And just same.
Okay, ready? Go.
Fast you step around.
Look at Rachel. Liz!
Where are you going?
Their steps aren't with the beat.
I know.
Are you stepping as you are?
I'm trying to
The experiment is compromised. They failed.
Pine foot.
I don't know what to do.
Okay, you guys stop. Okay,
Red. Your face is
So,
red.
I mean,
Is it really?
That's right.
Like 25. How? Are you entertaining?
Liz, how many times did you walk?
Like 24 or something like that.
Stephanie, how many did you hit?
24 or something like that.
Look at that.
And Reagan,
30.
Where? Okay, so in box B, you're gonna put 156.
Oh my.
Legitimately tired.
Yeah.
We'll tell why we got our exercise in camp.
I know, yeah, I don't need to do conditioning.
Go learning about how to
Okay,
I don't need
so
to go
we're
to the
gonna make
process.
it a little bit, I guess it'd be more difficult for you guys. Okay? We're gonna make half the
It'll be more
space.
difficult for you guys.
So, you all either stay on that side or you all
This
stay
side's
on this
wider.
side.
Oh, right.
Okay.
Stephanie can see it.
And wait, you guys have to go over to. We're all on the same
Oh,
on the
man.
same side.
Oh, this is
So this time,
What? I don't know. Hit the wall at all.
this time, this is gonna be
I feel like
the
this
wall. Okay, so you guys won't cross this line and you'll still count how many times you hit the wall.
I can't even move.
Okay, so we'll do, instead of doing 2 steps, we're just gonna do back to our 1, okay? So you wanna write that in? Okay. Ready? Go.
Stop.
Oh god, you're ready.
Look, Liz, just that one confused because of you.
Hey, you're stepping out of the swim.
I don't feel safe.
Right. Is a trigger word. Because that's what it's gonna be. Liz, how many times? 19.
I called my friend and
He literally had like a point two.
How many times did you go angry?
He's not smart.
21.
she said no. She called me back because I went
Okay, so you're gonna put 120. That's
shovel the snow. I went to shovel the snow off the driveway with my brother.
okay.
but
So
I was
3 of you can sit down.
Yeah.
She called me a brat.
Okay, so this time you gotta do like the whole space again. So I thought that the line's not there.
Thanks, Mama Fry.
Not done.
What? She said three.
She said
Yeah.
Yeah, thank you.
That's what I thought you could say.
Wait, what did you
We're gonna do 1 second. Just like that. Okay.
How many? 120?
Yes.
Stop, Leah. Freaking so hard.
Wow.
How many times can I clap between her one song?
They're still gonna like. I was like, what of one. Play music. I heard this happen. I saw him. That was awful. My friend and I are coming.
And I don't know.
So you're gonna put in box D. You're gonna put 52.
Got the whole in her face.
Later asked me what was the last song on the list.
Oh no. For the last one?
Okay, you guys can sit down, and you guys want to get your data from. Okay.
So I don't know I had to sing this song. Good job.
There you go.
Okay. So in box A, what did you guys get?
91.
Oh.
You gotta click the color. No, like right there.
Oh, I see. Okay.
Try again.
Okay. Well,
Try again. Click the color. Now try.
Use your finger.
Well, you used the mouse
It's
again
advancing.
after you did that, so. Sorry, I'm not trying to be sour.
You feel Logan.
do it this way. Okay, what did you guys get in box A?
91.
What did you guys get in box B?
100.
Okay, box C.
1.
And D.
God.
Okay, so
I didn't think. I
in
just
our
wrote it down
analysis,
wrong.
are you guys listening? In our analysis, we're gonna do so as we increased temperature, which is when we made you guys go faster, which was the 2 claps, the pressure, what happened to the pressure? If you look back at our data. So increased. Okay, so you guys can write that. So as temperature increased, the pressure also increased. So now volume, when we split the container in half, and they went in half the container, so as we decreased the volume, what happened to the pressure?
It decreased.
It increased.
It increased, yeah.
Oh.
It's it did.
Wait,
But the volume.
she said the volume decreased.
Okay, and then in when we happened, or I guess lessened the number of people, what happened to the pressure?
Decrease.
It decreased because they went slower than with more people in the box. Okay,
What's
so
the middle box?
what
Decrease, increase.
the last one was decrease. Okay, so the mathematical relationships, obviously you guys know direct and inverse relationships.
Right.
That was right. Who said that? Okay.
Oh, I don't know what the numbers are.
Okay, so for volume and pressure then, is it direct or inverse?
Inverse. Wait, inverse.
Okay. As direct. Okay.
Why did you take my number?
Okay, also for our graphs. Okay, for our graphs, the first one we're gonna have, let's see, we'll have temperature and pressure. So we'll put our temperature over here and our pressure over here. So that's what you're gonna draw first in that box. And what we said at the top was as temperature increased, which means as we went faster, our pressure what? It increased. So your graph is gonna look like that. Okay. Are you writing this down? Oh yeah, alright, you guys.
That's really exciting.
Okay, for the next one, what do you guys think it's gonna look like? For
I-
volume and
No
pressure.
copy.
For she can look up her
If notes can be
For volume and pressure, what do you think it's gonna look like?
You go like this.
No, it's just gonna go
Like
down.
this. Just down.
It not necessarily
But
goes
it's in a
down.
straight line.
It'll be more like
Curved
an
down.
L shape.
That. Like a curvy L. Like a C without the top.
If it's direct.
Like a backwards here.
A C without like this part. Which is like the bottom. Like the bottom of an E.
Draw it the right way.
Okay, for the last one, for the number and then the pressure, the amount of particles
Yeah.